All right, it is finally time to make a new custom actor from scratch. I have been talking about this for the past several videos, and honestly, I've been kind of putting it off because I sort of feel like it's the least useful and least interesting thing I can cover in the tutorial series, mainly because each actor is so different from one another that learning how to implement one is only going to help you with the absolute basics of taking that and then using it to implement another. But I'll at least cover those basics in this, and this is probably going to mark the end of the tutorial series for now, unless there are some other topics that folks suggest that need to be covered. But the reason I'm standing here in Indigo, I want to show you which actor we're going to be making. It's going to be this tree elevator. So the way this works is based on a switch flag. You hit the switch, it extends up, spawns some dust there at the base for effect, waits at the top for a minute for you to get off the elevator, and then it will descend back down, stop smoothly, and then reset that switch. So let's go ahead and get into it. For this, like I said, we're going to be starting completely from scratch. So that is going to include, I'm going to type out every part of the actor overlay by hand. I think an easier way for you to start, likely, is to grab another actor, see how this part's laid out, and copy that over and change things as needed. But I'm going to go over it by hand and show you, kind of explain every step along the way. So here we are in VS Code. The first thing we're going to do is take a look at where actors are located in the file system. Over in the Explorer here, if you expand source, going to go down to overlays, and underneath overlays, we'll see actors. And this will be every actor in the game. You see they all start with this OVL prefix. If you expand one of these, they're normally going to have two parts, a C file and an H file. There are some actors that have more files, like Ganon, for example. He's got some extra data that's included. We're not going to worry about that because our actor is going to be pretty simple, but this is where we're going to end up creating a new directory just like this. So why don't we do that? So that's mkdir, make dir, and it's going to be in source, overlays, actors, and let's name it OVL tree elevator. That sounds good. And then we'll create the two files that we need. So I'm just going to use touch for that, like we've been doing. I'm going to call it ztreeelevator.c and .h. Those will create the files we need. So now I can back in VS Code, Control P, look for ztreeelevator. There's our C file, completely empty. And then I'll also open up elevator.h. Excellent. First part, let's start in the header. So there are a lot of that. Let me open up another example to show you. There are these include guards that they're called. It's basically, you'll see this in almost every header in the repository. This is a way to allow you to include the same header multiple times, because in C, what this include preprocessor directive is really doing is saying, take all the contents of this file and just replace it, this list line, with the entire contents of that file. So if you didn't have these guards, this if in def define, and you just included the same thing multiple times, it would just copy and paste that entire file multiple times. And you get a bunch of compiler errors, obviously, because things are defined more than once. So we're going to set up this include guard, which says, if this value is not defined already, it means it's the first time that this header is being included. So we can go ahead, define it, write down all of our data that we need, and then close the if statement like that. And then when we include it again, if we needed to, this define would already be defined. It would catch it at this first part and skip including all of the contents. Anyway, I hope that explanation made sense. But we're going to do the same thing. So it's going to be if ndef is not defined, z tree elevator h. We're going to define it. And then ndif. Next, we need to populate this file. We're going to do just the bare minimum for now, and we'll keep adding to this as necessary to build up the rest of our actor functionality. So we're going to begin with the actor struct. So that's going to be typedef struct. Call this tree elevator. Elevator. And this is only going to have one member at the moment, and that is going to be an actor, and we'll call this actor. So every actor struct is going to have the first element as this actor type. And actually, I need to, in order for that to stop yelling at me, I need to include a couple things. Let's include ultra64.h and include global.h. And that should resolve there. So this actor, these are all the values that every single actor in the game is going to have associated with them in memory. And each instance of the actor will have its own copy of all of this stuff. And a lot of these values get set by the, I'm going to call it engine. It's not really an engine, but they're set by the engine for you, like dist to the player, yaw towards the player, how far away it is from water, things like that. Every actor just kind of gets those things set for it automatically. Okay, time to fill out the overlay file, which is the C file. These usually have a header. Let me just steal the header from one of these other guys. It's comment header. You don't need this, just to help stay organized. If you come back and look at this later. So we need Z tree elevator overlay VL tree elevator, and this is going to be a switch controlled elevator that looks like a tree. Excellent. Fantastic description. Next, we need some includes. Obviously, we need to include our header that we just created here. So that's going to be include z tree elevator.h. I'm just hitting tab to autocomplete in the IDE here. The next is a whole bunch of things that aren't going to make sense yet, but I'm going to kind of do them in order. First is this define for flags. I like to keep this at the top. We're going to use it in just a moment, but the two flags that I recommend you use almost all the time, these are currently unnamed. They may get better names in the future, but that's going to be actor flag 4 and actor flag 5. Essentially, what actor flag 4 is saying is to keep updating this actor even if it is not visible on screen. And actor flag 5 is keep drawing this actor even if it's not visible on screen. Now, for performance, you may not want to use 5, you may not want to use 4 if you can get away with it. But I think as a starting point, just begin with 4 and 5, and then as you flesh out the functionality of your actor more, you may be able to turn these off, but we're going to keep them for now. Next, we need to create forward declarations for the actor lifecycle functions. That's going to be void. I'm going to use a common prefix for all of our functions. This is just a standard practice. Again, if I look at another actor, they all have this prefix of the actor name. So we're going to follow that convention. That's going to be tree elevator init, and this needs an actor pointer, and it needs a play state pointer. And we need 3 more. Next is going to be destroy, next update, and next draw. So I call these the lifecycle functions. The way when an actor is spawned by either another actor or when you load into a room that has that actor, this first function is going to get called init. And this gives you, as the programmer, an opportunity to set up anything and initialize stuff. It's only called once per actor, and it's guaranteed to only be called once. The next part, this update, this is going to be called every single frame while the actor is alive. And likewise for draw, this is going to be called every single frame. So the update function is where you'll do all of the logic for things like moving the actor or setting different state flags or waiting for switches to get set, that sort of stuff. And drawing is where you're actually going to put the commands to draw the display list. So these are separate because they are called at different parts, different times depending on the actor category. I don't really want to get into the details of how these are different, but just know it's good practice to respect the life cycle, put all your drawing stuff in draw and so on. Now, I said that the engine is going to initialize the actor. It needs to know how to find this function. So we're going to provide that for it with an actor init struct. It's going to be const actor init, and we're going to call this tree elevator init vars, just like that. And if you are using, well, let me just jump in here. These are the fields that we need to fill out. We got to fill out all of these guys. First is going to be the actor ID. So we're going to call that actor tree elevator. This doesn't exist yet because we haven't added it to the actor table. That's where this enum is coming from. So let's do that real quick. Control P actor underscore table.h down at the bottom. Remove this comment. Find actor tree elevator, actor tree elevator. Leave this allocation normal and tree elevator. Well, back here, you'll see this turned blue because it recognizes that. If I control click, I jump to the definition in the actor table. Next is the category. Now there are, we can look at them. This is going to be actor cat BG, but there are several different categories of actors that you can fall into. There's switch. You'll never guess what type of actors should be actor cat switch. There's a special one just for the player, things for explosives, props, bosses, doors, chests, and so on. We're going to use BG, which is kind of like the category for things in the background, hence BG. And then next, we're going to put the flags right here. Now, I could just, not use this define like I had before. I could just put that right there and that would be fine, but I like to have the flags up at the top. It makes things easy. If this list of flags grows really long, it kind of keeps things nice and clean down here in the init. The next piece that we need is the instance size. So you see we've done ID, category, flags. Object ID, that's what we need. This currently doesn't have an object, so I'm just going to say this requires the gameplay keep, object gameplay keep, yeah. Gameplay keep is a special object that is always loaded. Next we need, what was it? This is the instance size, yeah. So we're just going to do size of tree elevator. So this is the size of the struct. And then we're going to provide all of these functions that we have forward declarations here for. This is going to be tree elevator init. And then we have destroy, update, draw. If you look at the actor init struct, these are actor func types. And we'll look at the type of that real quick. So an actor func type is a function that returns void and accepts a pointer to an actor struct and a pointer to a play state struct. And that is exactly what we have here. So this is a compatible type. We're just going to cast this. We don't get any compiler warnings. Cast this to actor func. Excellent. Now we can put the implementations in for these guys. So I'm going to copy these 4 functions, paste them down here. Remove that semicolon, and just do this for each one. Add the brackets. Cool. There's our overlay sorted. Next, overlays need to be included in the spec file. I'm going to Control P, go to the spec. We're just going to search for OVL underscore and jump to the last result here. That's our Paul's voice. I'll copy that, paste it right here, make the changes I need. So instead of Paul's voice, let me do like this. Paul's voice tree elevator. Just like that. And this needs to change. This is Z tree elevator. So this first entry is for the include here, this build. We're going to be including our overlay that gets compiled. So .c is the source code. .o is the compiled version of that source code. So include that guy, and then again, include the reloc that I don't fully understand, but needs to be there. Great. Now let's pop our actor into our scene. I am gonna replace this Pole's voice actor. So I'm just gonna rename him. This is gonna be actor tree elevator. And because it's a custom actor, I need to change the name here. Actor tree elevator. We can export that guy. Excellent. Now let's make run. No, we touched the spec, so we got to do a make clean. And then we can do a make run. Map selected into our scene. Here we are. No Pole's voice, but we don't see our actor. That should be obvious to you because our actor is doing literally nothing at the moment. So let's jump back over to our source. So let's draw something as a little test. There is a helpful function that helps with drawing. It is called gfx_draw dlist OPA. You may have seen in the autocomplete, there was also draw dlist XLU. These are the two of the three buffers that the game uses. OPA is opaque, so this is anything like that is solid. XLU is translucent or transparent, anything that has some not like a value for opacity that is not 0 or 1. And there's also another one called overlay. We don't, you're hardly ever going to be using overlay. This is for things like the icons that are drawn on the HUD. Anyway, draw dlist OPA. That's going to take a pointer to play, and then a display list. What can we draw? Let's draw something from gameplay keep because we already have that as our object here, and we know that gameplay keep is always going to be loaded no matter what. So first thing I need to do up here is include the gameplay keep header. So include assets, objects, gameplay keep.h, and I can control click right here to jump into it. Let's look for something fun. Oh, actually, I know bomb chews are in here. So let's draw a bomb chew. And paste that guy in right there. Cool. Let's run now and see what we get. Nice. There's our little bomb chew display list. Now, this important to note, this is not a real bomb chew. This is just the mesh that a bomb chew uses. And I can prove that to you if I search. Let me search for G bomb chew. We will find here in the actual bomb chew actor, it is drawing the same dlist as well. It's doing it a different way because it's setting the color of the bomb chew in code. That requires some other setup. We're not doing that in this case, so that's why ours looks gray, but hope that makes sense. Now that we've made some good progress and our actor is in a workable state, I think it is a good time to commit these changes. So I'm gonna move this bit from draw. I don't actually want that. I'm gonna do if I do a git status, you'll see all the files that I've had changed. I'm gonna commit all of these. So git add -a, git status again. We change the actor table. You'll see all of the dungeon scenes that we're committing changed as well because we changed what actor was in there and re-exported with FAT64. Update to the spec file to include the overlay, and then our two files that make up the overlay. Perfect. Git commit m 3 elevator. I'm just going to say whip. Terrible commit message, but that's okay. Next, let's make some progress on something small before we get into our model. Let's spawn some dust. So I'm going to need a function for this, and I'm going to call it in tree elevator updates. We'll just call it every frame for now. We're going to do tree elevator spawn dust, and this is going to take this play. I tend to just have all my functions within an actor take these params, this play, and that is not defined, so I need to fix that. That's going to be a tree elevator this, and we're just going to do a cast tree elevator this x. And I'm actually going to go ahead and put this in all of my lifecycle functions because I think it is much nicer to work with if you do this cast at the start than in all of the subsequent functions like tree elevator spawn dust. Let's go ahead and make a forward declaration for that. That's going to be void, and it's going to take a tree elevator pointer instead of an actor pointer. We don't have to do that cast anymore. The only place where we're receiving the raw actor is in the actor lifecycle functions. All of our other functions that we make are just going to take that struct, and it's a little bit easier to work with. All right, spawn dust. Let's implement this guy. Go down here to the bottom. The reason we need the forward declaration is because the implementation of this function is coming after its usage. You see it's in like linearly in the file. If I moved this function like up here somewhere, I wouldn't need to do that, but just for organization, I like to keep the 4 lifecycle functions first in the actor struct, or excuse me, not the actor struct, in the overlay source. Okay, spawn dust. We're going to use a function that is, let me see if I can remember the name, effect ss dust. Yeah, effect ss dust spawn, I think. Capital S. Yeah, perfect. So that's going to take all kinds of parameters. Let's go ahead and implement those. So it's going to take play, draw flags. I think we just always pass a 0 for this. And we need a pointer to a pause. We need a pointer to velocity. We need a pointer to acceleration. And then the colors, we need pointer to trim color, env color, and then we've got scale, scale step, life, and update mode. I think that's another one we just always pass a 0 to. All right, so this is gonna spawn our dust once we give values to all of these. So make some space here. Let's start with the primary color. So the type of that was color underscore RGB8. So color RGBA 8. Trim color. And this struct is just 4 bytes for each channel. So let's start with all white dust just for now. So that's the R channel, green channel, blue channel, alpha. And we'll do the same for the env color. Env color, let's keep that like such as. Next, we need the position. Okay, for now, let's just put the position is going to be this actor world pause. Next up is velocity. And the vec3f is just 3 floats. You see its type here, 3 F32s. So start with the velocity. We're going to give it, let's make kind of like, just to get something drawing, we'll start with something that kind of looks like steam, I guess. So let's do 0 x velocity, 1 y velocity, and 0 z velocity. So this is going to cause it to kind of go straight up. And similar thing for the acceleration, except I'm not going to have any acceleration. We'll just give it some constant velocity. The way these two interact is velocity is added to its position every frame, and the acceleration is added to the velocity every frame, I believe. I'd have to dive into this to know for sure, but I'm pretty sure that's how it works. Remaining parameters, we've got scale. Let's give this a scale of 10. And scale step. So this is saying it's going to start at a size of 10, and it's going to increase by 10 every frame, I think is how these two guys interact. And then we need life, S16 life, we'll say 40. Life is the duration in frames for it to last, and because the game runs at 20 frames per second, this is going to last for 2 seconds. All right, I think that's everything. So, and yeah, we're calling this in our update function. So we should have a little spout of dust, or I guess it'll look like smoke or steam because it's white, coming out of that spot where our actor is placed. Nice. There it is. Isn't that beautiful? So now that we've got this function for creating dust, this little wrapper, our wrapper around this effect SS dust, we'll extend this later, and Obviously, we'll give it some brown dust to better reflect the wood, but we've got a good place to start now. I think it is time to switch over and work on the model. So we're going to head back to Blender for that. This is the part of modding that I am not very good at. Fortunately, the elevator is pretty simple, just kind of a big cylinder, so I should be able to pull it off. Let's get started. So I'm going to hit Shift A, add a mesh, and I'm going to add a cylinder. And then down here in this, I can open this add cylinder. I can change different values. So right now, this is too many sides. I can click here and drag to reduce the number of vertices or use the arrows. Let's go with 8. 8 seems fine. Let me change my view mode here. We've got our cylinder. Now let's create a Fast64 material to decorate this with. Create Fast 3D material. And this is going to be a vertex colored texture. Yeah, we'll do vertex colored texture. And then I have some textures for this that we're going to use in my downloads. One of those is incorrect, but we want this one, wood 6464. Pop that in there. Good first start. Now the top is going to use a different one, so let me fix that other texture real quick. All right, saved the wrong file there. So I'm going to create another material. And actually, let's rename this. This is just going to be wood outer. I guess this is bark, right? Let's call it bark. And this one is going to be wood cut. Also, let's make this a vertex colored texture. Expand this, open, back to downloads. This is what it should look like. Fantastic. Now I need to assign the texture to the correct faces. So I'm gonna hit tab, select the top. There's not really gonna be a bottom, is there? Because this is gonna be in the ground. So I'm actually gonna delete this bottom face because we will never see it in game and I can save on some tries. So select this top face now and then select wood cut and click assign. Now, this looks pretty horrible. We need to fix the UV scaling. First, let's do the outside because this is going to be pretty easy. I'm gonna need to make a seam somewhere. I'm gonna choose an edge kind of towards the back. If I'm looking at it front on here, this opposite one is gonna be the seam. This is where the mesh kind of gets cut apart and unfolded to then apply the 2D texture onto it. So I'm gonna select this edge, hit U, and mark seam. And then I'm gonna control click, go into the face mode first with 3, and then alt click right here on this face, and that will select all the way around the mesh. And I can hit U and unwrap. And that will attempt to use the, I think I need another seam up here. So I'm gonna select the top part, U, mark seam, and then we'll select these faces again. Unwrap. Let me go into the UV editing tab. Okay, it's unwrapping on this diagonal, which is annoying. That is not what I want. I think it's probably 45 degrees. So I'm gonna select all of this and just hit R45. Yeah. And I'm not seeing the texture behind it. So I can hit this drop down here and select wood 64 by 64. So now we'll see each face, like for example, this face right here on the mesh corresponds to these coordinates in UV space. This is way too small. So let me select, I can click the correct buttons, select all the faces, and I'm just gonna hit S to scale with my mouse over on the UV editor and scale this up to something around, well, that's a little too much. We'll say like right there is looking fine. Now we're getting some tiling. We can alleviate that a little bit in the material settings. Go down here, I can turn on mirror T, and that will mirror the texture along the y-axis. So S is the x-axis of the UV coordinates, and T is the y-axis. That mirroring helps. Let me see what it looks like. That's a little too much. I'm just gonna leave on mirror T, and maybe now I'll change the scale a bit, make it look a little, see if I can hide that mirroring a little better. There. That's not terrible. Still kind of obvious. What's it look like without? You know what? I think it's fine without. We're going to keep it without. Crunch that down a bit. Perfect. All right, now let's do the top face. Let's select this top face. I can change the texture that I'm previewing here. This right now is an n-gon. Well, it's an 8-gon because it has 8 sides. So I'm going to poke this. I can right click here and poke faces, and that is going to turn it into all of the triangles. And the reason, there's a couple ways you could do this, right? So instead of poke, you could hit Control T and triangulate it, and you'd get a shape alignment like this for your mesh tries. That's not going to be very helpful for us because we want this to be like a symmetrical wood face. So I'm going to right click and poke. That gives me all these triangles. I'll select these faces, and then over here, I'm going to make sure I'm in vertex selection mode, and I'm going to change my snapping type. Instead of increment, change that to vertex. And now I'm going to fold this mesh in on itself. I'm going to grab this vertex here and bring it over and snap it to that one. And I'm just going to go along and do this for each. All right, now we've got that folded in half. Now let's fold that down, fold it down, fold it down. So now all the UVs are stacked on top of each other. Let me scale this up and position it correctly. So I think this point is the center. Yes, we want this to be rotated. So that point is in the center. Pop that right down there. And another trick, I can select this vertex and hit Shift S, cursor to selected, and then change the way I scale. By up here, I can scale by the 2D cursor. So now when I hit Shift S, it's going to keep that point constant and scale outwards. Then I'm going to rotate this a little bit. Something like that. And we're kind of going off the edge a little bit and getting some parts of the wood where it's tiling. So I'm going to clamp, and that's going to make it so even those parts of the mesh that are sticking too far over the edge and kind of starting to overlap here, it's going to take whatever the pixel value on this last edge is and just extend it outwards. You don't do that, like if you do mirror, then it'll grab whatever is on the other side. If you leave it unchecked, it's gonna just tile it flat. Hopefully that makes sense. Let me see if I can improve how this looks a bit. Pull this guy in. There we go. Maybe down here. Yeah, that looks good. Now we're getting some nice rings. That looks decent. Perfect. Well, perfect as I can do. Anyway, all right, let's export this guy. For anything else, let's give this a better name. Hit F2. I'm gonna call this G tree elevator DL, sure. And then hit N to expand our export, FAST64 export stuff. I'm gonna open this OOT DL exporter. And we're gonna be, for folder, this is gonna be our object folder. So I'm gonna do object underscore tree underscore elevator. And then for path, should have, yeah, tutorial OT mod assets objects. We wanna export into the mod assets object folder. And export that guy. We also want this to have collision. So if we scroll down, there's another OOT collision exporter. Expand that. Don't need custom file name, folder, just like before, object tree elevator. And I can just steal this path, paste that in right there, export collision. Cool. I'll explain the collision in just a moment, but do both of those for now. And if we look in the directory, mod assets, object tree elevator, we'll have our tree elevator DL and tree elevator DL collision. All right, let's jump back to Visual Studio and finish the setup for this guy. So we are going to need a new entry in the object table. Control P, object underscore table dot H. Duplicate the last one, which was our feather. Object tree elevator And right there, same thing in all caps, object tree elevator. And we need an entry for it in the spec. Control P spec, and we're going to look for object underscore and jump down to the end of that. Oh, which is right here. I'm going to grab the one we did for the feather, duplicate that, paste it right beneath, and rename. Tree elevator. Tree elevator. Now, I'm not actually going to be calling this tree elevator for the file name, because if remember looking at our mod assets directory, we have given this a different name. So it's going to be g tree elevator dl .o. We want to grab that one. And we also want the collision. I can copy that. Have another include there. So now those two files are what's going to make up our object. And okay, we changed spec, so we need to do a make clean. Before we do that though, let me just set up here. I already changed this, but yeah, this was object gameplay keep. Remember, now that we're actually going to be using an object for this actor, I'm going to change that to object tree elevator. And because we're going to be using assets from this new object, I'm going to add an include directive for that. So include assets, objects, object tree elevator. And if I look back here, we want to include both of these header files. So I'm going to grab tree elevator dl.h. And there was also dl collision, if I'm not mistaken. Yes, perfect. And this is yelling at me because we don't have, the mod asset script hasn't run yet. But once I do a make clean and a make run, those errors should resolve themselves. Okay, successful build. Oh, the black screen finally happened during the recording. So when this happens, just close Project 64, and then you can open it again. You'll get this pop-up, terminate Project 64, hit yes, and then close this again. That will kill the process that was running in your terminal. Then you can just do a make run again. And like I said, this only seems to happen to me like once a day. I don't really understand why, but it's just a symptom of doing the booting directly to it. All right, so not only is our tree elevator not there, but our smoke is gone, our steam. That is because we have now introduced an object dependency. Before, this was depending on gameplay keep, which was already loaded. Now it's depending on object tree elevator, which is not present in the room in the scene. So back to Blender, we'll need to select the room that this is in, room 0. On the objects section, this tab, objects tab, we no longer have a Pulse voice in this room, so I'm just going to change this one. This is going to be object tree underscore elevator, like that. And we'll export the scene there. And that should get us our steam back, but we're still not actually drawing anything. So let's also update the draw. We're going to use that just like we did before, gfx underscore draw dlist OPA, play, and what's the name of this? G tree elevator DL. We're just going to draw that guy. And if I control click into there, we'll see there, this is our DL. And you'll see we've got 2 hits now for it. And there's one in mod assets and one in assets. You can just ignore the one in assets. That's just kind of an ephemeral temporary thing. This should be finding it. I think those squiggles will disappear once VS Code is happy, but let's do a make run, see if we get our steam back, and see if we're able to draw that tree correctly as well. There we go. So now we've got our tree, although it is quite tiny, and the steam coming off of it like before. We got to fix a couple things that I see wrong. First, like, is very obvious, the scale is quite far off. Second, the origin of the model is not correct. It's not, well, it's not a very useful location. So it's right in the middle of the mesh, and that's not what I want. I want the origin to be this point at the very top. So I can, what I'm doing here is I go into edit mode and I select this vertice. I do Shift S, cursor to selected. That's going to bring the 3D cursor to whatever I've just selected. Back into object mode with tab, right click on the mesh, set origin, origin to 3D cursor. That will move our origin point to the direct center top of the mesh, which is what we want. And just to keep things nice, I'm going to take the cursor back to world origin and then selection to cursor, and I'll drop it down. So now this mesh, I like to keep the mesh origins centered in the Blender origin as well. Although truth be told, it does not matter at all. So we need to re-export our DL and re-export our collision. And the scale was also off as well. So let's change the scale here. It was set to 10. So I'm going to actually scale this up in the Blender world. I'm just going to do S to scale, and we'll scale it up by 10. That gives us a bigger stump. And then we want to re-export the DL, re-export the collision. We'll do a make run. What I expect to see is we'll see the steam and a lot of Z fighting, because it's now going to be placed exactly on the floor. Yep, and there's the Z fighting, and our scale looks good. So this is what we want. Now, what I like to do for this actor in particular, I'm going to change its location in the scene to be slightly off the floor. So I can hit G, Z, move that on the Z axis. And I'm going to move it up to right around there. That's good. This way, we're going to avoid all of those Z fighting issues. Another solution, what you could do is move it up in the actor init. Like if I go back here in my init, I could do something like, you know, this actor world pause Y 10 units, and just this would then allow you to place it exactly on the floor in your Blender scene, and the code would then move it 10 units off the floor during the init. But we're going to keep things simple. We're not going to do any world manipulation stuff there. Just going to have it move it up off the floor. Let's see what this looks like. Do a quick make run. Oops, I forgot to export my scene. There, export scene. There we go. That's what we like to see. And we'll see if the collision is working correctly. It is not. That is because we haven't even set up the collision yet. Okay, of course. Why did I think that was just going to work? So let's do that next. First, though, this is a good time to commit, because we're in a pretty happy state. Everything is looking good in our source file, so it's a good check mark. I always like to commit in a working state. So if you are then looking at the history, any commit that you go back to, it's buildable in some form. Like this isn't complete, but at least it, compiles, it doesn't crash, stuff like that. Let's go ahead and commit. We'll do a git status, commit all this stuff, git add -a, git commit m, tree elevator DL, and oh, actually we haven't done the collision yet. So tree elevator DL, looking good. Next, we need to set up the collision, which I completely neglected to do. So we're going to do that in init, and it's pretty simple. First, we need a variable to hold our collision header. So that's going to be, we need a collision header pointer. We'll call this call header, and just set this to null to begin with. And next, we need to get the collision header out of that object file. So that's going to be collision header underscore get virtual. And we want to grab G tree elevator, the second one right there. And we're going to store it into call header. So this function is going to grab this collision header, which is all of this data that's in our object file, and get a pointer to it in this call header. It's doing like some address translation. Now the next part, I haven't talked about this at all. We're going to need to go back to our actor table. Oh, I'm sorry, excuse me, not our actor table, our actor struct definition. We are now changing our actor type. Instead of just a regular actor, we're going to make this a dynapoly actor. This is going to be now dynapoly actor. And convention is to also change this to dyna to make it easy. So everywhere that if I was going to do this actor, now this is this dyna. Like so. Yes, it does. It definitely does. C tree elevator.h. Dynapoly actor dyna. Yeah, that's correct. VS Code is being particularly slow for me today, but now we'll be using this dyna instead. All right, back to setting up the collision header. We need to set the ID of our actor based on which, when we're actually instantiating the collision, it gets a certain ID, so it's going to be this dyna bg ID. I'm sorry, I know that was a terrible explanation, but just bear with me. I don't fully understand how all the dynapoly stuff works, but it's going to be dynapoly underscore set bg actor, and this needs play. It's going to take a pointer to the collision context, so that's play call context dot dyna, and we need this dyna actor as well. That's our actor pointer, and then our call header pointer. Whoops. Call header, just like that. Now, the important thing to remember is when you initialize, like this is doing some allocations, so we need to release this. Now our destroy function, or that's called when the actor is killed, we need to release these assets or these resources back. So we're going to do dynapoly delete bg actor, and this takes a pointer to the play state, takes a pointer to the dyna collision context, so that's play arrow call context dot dyna, and we also need the ID, so that's going to be this dyna bg ID, like so. This dyna also, this dyna actor world pause. Okay, I think that is all we need. But let's find out with a make run. Hopefully we can now step on this guy. Yes, so we are standing correctly on. You can hear the sound effect change as well. And if I roll here, it's rolling on dirt. Now I'm on sand. Now I'm on dirt, stepping up a little bit. Perfect. So, and it looks like, yeah, our collision matches correctly. Okay, we can even get the, here, unequivocal proof that it works. Link can stand on it with that little step. All right. I'm going to close this file and see if this fixes tree elevator. This issue that I'm having with Visual Studio Code not recognizing that does indeed exist. Don't know why it is being so obnoxious. I'm just going to restart it. Code dot. That will open it back up. Open on another monitor for me. There we go. Now, looks like things are loading in and it's happy. All right, this is another good checkpoint. So we got the collision working. Git status, git add source, git commit -m. You don't have to do this -m. If you just do git commit, it will prompt you to then write a commit message, but I like to do -m, it's faster. Collision for tree header working, sure. For this, we want to think about all of the different states that our elevator can be in. So let's enumerate those out and then we can implement it. So let's see, we're going to have the initial state. We're going to be waiting for wait for switch. We're just kind of idling there at the bottom, doing nothing. That's going to be one state. Once the switch is triggered, then we are going to raise up to our max. When we get to the top, then we're going to, let's say, wait to lower. We're just going to chill at the top for a few seconds. and then we're going to actually do the lower, and that ends our life cycle. So after the lower state, we go back to wait for switch. So all of these will link together. Now, a common pattern that you will see in many of the actors in OOT is to use something called an action func and drive state changes by changing that action func. We're going to go back to our header file here. We're going to need to add some more things. So first, we're going to have a new entry here. This is going to be tree elevator action func. This type doesn't exist yet, but we're going to name this action func like that. So let's define this and add a new type def here. This is going to be type def, and we're defining a function pointer type. So that's going to be a function that returns void and tree elevator action func. That's our name. And it's going to accept a pointer to our struct, which is tree elevator. Oops. And a pointer to play state. Okay. So now this is, we need a for declaration for this guy as well. So I'm going to do struct tree elevator like so. Now everything's happy. So we've got a temporary for declaration for the struct so that we can use it here. And the full implementation then is coming down here. Oh my gosh, I'm turning on too many things, making this too complicated. Essentially now we have a new member for our struct that I can access. If I go back here, I do this action func, that is going to be this guy. And we're going to assign different function states to this based on where we want to do. So we know that our first state is waiting for a switch. So let's create a for declaration for that. Let's just call it wait for switch. You could call this idle, something like that, but I'm going to call it wait for switch. And then for the action func, another common pattern is to have setup functions that you can call to transition into these states. So we've got our wait for switch action func state. I'm going to add another one right above this that's going to be called setup wait for switch. And then I can call that right here, tree elevator setup wait for switch, pass it this, play, like that. Let's get an implementation for these guys. Drop down here to the bottom. Add the braces. Setup wait for switch is just initially very simple. We're just going to do this action func equals tree elevator wait for switch. Now in our update routine, let's go ahead and get rid of this spawn dust. In tree elevator update, we're going to call that function. So this action func, and then call it this play. Now I hope you're kind of starting to see how this is going to work. So the tree elevator update function is called every frame, and its job is to then call the action func that is currently set, and that will control whichever state that we're in. Now, initially, because we're in a init, we're going to just call setup wait for switch. This is just going to bind the action func to this function, wait for switch here. And here we're effectively doing nothing. Now, let's say as an example, let's move our spawn dust to this wait for switch. So tree elevator spawn dust, this play. Now, if I run this, we're going to get pretty much the exact same behavior as we had before, but now we've got this extra layer of indirection going on. And I'll show you why that is helpful. So yeah, this is just like we had before. It's as if nothing changed, but we've got this extra layer of indirection. And it is very helpful. So to illustrate that, I'm going to show you some debugging tools that I like to use. So first, we're in a good spot. Let's go ahead and commit this. Git commit m, add action func to tree elevator. I'm going to create a couple new files. I've got them here. I'll have a link in the description for this gist. So I want to create, let's go back to Ubuntu. I'm going to touch the file include debug util.8. And I'm also going to make a source file for this. This is going to be touch source code debug util.c, like that. And then I'm going to grab the raw for this file. Just copy that to the clipboard. Back to VS Code. Control P. If I search for debug util, now I've got the header file. Let's start with that one. And I will paste all of this stuff in here. This first part is what's going to go in the header. And the second part is going to go in the C file. So I'm going to select all of this and cut. Control P, debug util.c. And I'll paste it in right here. I don't need these comments anymore. Delete these comments as well. All right. Looking good. Visual Studio, yeah, for some reason it's just very, very slow, taking a bit to catch up with me. I'll go ahead and include global.h. That should get rid of those. Okay. Now, I'll explain what this does in just a sec. We need to add it to our spec file so it will be accessible to us. We're going to add it in with the rest of the code files. So I'm going to look for source code. We've got here this segment, the code segment. We're going to add this all the way at the end. I'm going to do include, and this is going to be build source code debug util.o. Now, what this lets us do is pretty cool. A couple more things to set up, though. I'm actually going to, let's remove this include global part, and I'm going to put, let's go to global.h, and I'm going to include debug util here. So it's accessible globally. All right, next, we're going to open up zplay.c. We're going to look for this play update function. This is the main game loop. Like this handles for every frame, this play update calls, and this is doing all of the stuff. You know, it's drawing the interface, it's drawing the world, it's updating all the actors. We're going to go to the very end of this function, right after environment update, and I'm going to add one of the new functions that we have, which is debug print draw. And this takes graphics context. So that's going to be this state GFX context, just like that. Bear with me. I know this is a lot of setup, but you're going to see in just a moment why this is so powerful. So let's go to our tree elevator. Now, I can start doing some prints. So I'm going to do debug print this on line 1. Oops. Or line 0 rather. I'm going to say hello from update. And then let's drop down here, do the same thing, debug print. Let's print this on line 1 now before we're printing on line 0. It's going to be hello from wait for switch. Let's also add one to init. Why not? We'll do debug print on line 4, sure. Init, my ID is, and let's do %d. We're going to pass it this guy, so we'll do this dyna bg ID. All right. Now, if I run, you're going to see this utility allows us to write text directly to the screen. You'll see here we've got hello from update, hello from wait for switch, and init, my ID is 0. So the way I have these functions working is if it is purple, it means it was drawn that frame. And if it is gray, it means it was drawn in a previous frame. So let's make this a little more dynamic. Instead of hello from wait for switch, let's print the current frame. Current frame, that is an unsigned variable. So I'm going to use %u, and that is play gameplay frames. Yeah, play gameplay frames. And let's run that again. The different format codes are C format codes. You can look online for different all the different format codes to print different types of variables. So let's jump in here. Yeah, so you'll see now I'm able to print the current frame. So this is extremely useful. I use this all the time. Pretty much every time I'm making any sort of change, I'm constantly printing stuff to the screen. Very helpful to see like an easy look into how your actor is behaving or whatever change if you're trying to figure out how something works. So nice to just be able to just print something right to the screen like that. Use it absolutely all the time. So I'm going to go ahead and delete these prints for now. And now that we've got that working, I'm also going to commit this stuff. So git status, yeah, so we want to include, git add include, git add spec. I don't know why I'm doing this, I'll just do it all. Git add -a, git status, yeah, that's all our guys. So I'm going to commit this, debug, print utilities. Extremely helpful. All right. Let's now flesh out the rest of these states. So I'm going to start with the function declaration. So we have our wait for switch. Let's add another pair of states. This is going to be raise and setup raise. And then we've also got wait to lower and setup wait to lower. And then finally, we just have lower. Looking good, looking good. Now, the wait for switch, we are going to, what this function is going to be responsible for is every frame checking to see if a switch flag was set. So let's talk about actor params. We have touched on this a little bit with all of the the treasure chest and the other types of actors like the Lizolfos and things like that. So here in my tree elevator, I'm going to change the params this byte here. We're going to use, let's say, the lower byte, these two values. This is going to be our switch flag. So I'm going to, let's use switch flag 8 for this, for example. Now I also need to add a switch to this scene. So let's grab this guy right here, the switch. It's going to duplicate that, bring it over, put it right here. We need to rename this. This is no longer switch flag 2, switch flag 8. And I know that's this guy right here. So let's change that. So now we've got a crystal switch that is going to set switch flag 8. This is also in the wrong room. So let me parent that to room 0. Perfect. Now back in our actor overlay, I'm going to make a new macro here. And I'm going to call this switch flag, switch underscore flag. It's going to take a parameter of this, and we're going to do this dyna actor params. And we just want that lower that lower byte. So we're going to do a mask. Switch flags only go up to a maximum of 3F, so that's why I'm doing the mask like this. That is going to allow us to extract that value that we just set, 8, here in our params. We'll be able to pull it out in our overlay. So the params are a way to pass information at like scene creation time to your actor, and you can, I'm doing it this way. I could have just as easily put it in the upper byte, and instead I would then first do a shift and get it out like that if I wanted to there. So now if I wanted to use the upper byte, I could go back to my scene, and instead of putting it there at the bottom, I would then stick it here like that. Hopefully that's making sense. The params can be kind of confusing, but bear with me. It'll start to make sense as you do it more. Let's revert this change back. Okay, now back in our wait for switch, we're not going to be spawning dust, so let's get rid of this. Let's say and have an if statement, flags get switch play, and then we'll use our macro, switch flag this. That way we don't have to keep doing that, this Dyna actor params and OX3F thing every time. So if the flag is set, then we can change state. Then we're going to change to tree elevator, setup raise. Just like that. Let's add implementations. Just add some empty implementations for these guys. Setup raise. We know one thing that this is going to do is set the action func to tree elevator raise. And we'll do the same thing for all of these guys as well. All right, so in the raise action func, let's do this. Let's say we're gonna debug, print it on line 0. We'll print it on line 1 actually, in raise. And here in setup raise, we're gonna do debug, print 0, setup raise. Okay, now let's see if we've got everything wired up correctly. We can make run. So what should happen when we hit that crystal switch, we're going to see some stuff printed to the screen. First, we're going to have the setup printed, and then, where is my switch? You know, I actually don't think I even exported my scene after I made that update, so that is my bad. Just had to go back to Blender and click that re-export scene button. There we go. There's our switch. Let's see what happens when we hit it. There we go. Setup raise, in raise. So hopefully that's starting to illustrate just how the action func process is going to work. Okay, now we are going to really get into the weeds here. Let's start implementing this raise behavior. Let's start with a very basic implementation. We're just going to have it move upwards for 2 seconds. So to do that, we're going to use a timer. And this is another common pattern that you'll see a lot in the vanilla actors. They have a value, a struct member. Usually it's like a short, we'll say, just call this timer for now. And in setup raise, we're going to set that value. So this timer. And again, we wanted to have, our frame rate is 20 frames per second. So our timer, we wanted to move up for 2 seconds. We're going to set our timer to 40. And then here in our raise function, we're going to use, there's a macro built in called Decker that I like, which is, I'll show you in just a sec, this timer. Look at the details of this. Essentially, it's taking a value. If it's equal to 0, it does nothing. Otherwise, it decrements the value. And we can wrap this in a if statement like this. So Decker timer equals 0. And this will, like I said, every time this action func gets called, it's going to decrement timer. And once it hits 0, then we know to stop and do something else. So if we hit 0, we know that we're done raising. We're going to do tree elevator weight to lower. Oops, setup. Setup weight to lower. Otherwise, let's just add to the Y position. This Dyna actor world pause Y plus equals, is 1 going to be noticeable enough? Let's do 2. We'll just add 2 units to the actor's Y position for effectively 40 frames for as long as this function is going to be called. And then we'll go setup weight to lower. Let's add a debug print here as well. Debug print setup weight to lower. Just to see. Let's go stand on it and let it rise up with us, hopefully. There we go. So we have the basics, and now it's just waiting to lower, but of course we haven't implemented that, but we've got our little elevator that now comes up. And we can reuse that timer to do other things. So here in setup wait to lower, we know that if we're in here, we're no longer going to be calling this raise action func. So no problem to set the timer to something else. We'll say it's going to wait up there for 5 seconds. Waits up there for 5 seconds, just 20 frames times 5. And here we're going to do the same thing. Do this decker. Wait to lower. If timer is equal to 0, then we're going to set up lower. And we're not doing anything else. We're just kind of hanging out there. So we're not going to have an else. And in here in setup lower, let's do the same like we had before. Whoops. This timer 40, tree elevator lower. We're just going to really do the inverse of what we did before. This is going to be setup wait for switch now, because we're restarting the loop. And instead of adding 2 units, we're going to minus 2 units. Another part of setup wait for switch that we need to do is clearing that switch. So we want to reset the switch flag when it gets back to its original start. We're going to do that here. We're going to do flags, unset switch, play, and then use our macro, switch flag this. So every time this setup wait for switch function is called, it's going to turn off the switch flag. This is important. Otherwise, our thing would immediately jump right back into the setup rise function and would just go up and down. Maybe it's worth showing that what's happening as just to illustrate the point. But we should be starting getting close to the functionality that we want. All right, we're rising up, and it's gonna wait for 5 seconds, go back down, and immediately start back up again because it didn't turn off that switch flag. Hopefully that makes sense why we're doing that. All right, let's turn that back on. Now, I'm using some this value 40. It's important that this is the same for both the raise and lower. I'm actually going to lift that into a define. Let's do tree elevator travel duration like that. Pop that down there as well. And up here, I'll just add another define. Define tree elevator travel duration 40. There. Now I can control it from up here at the top, and I don't have to worry about changing it in multiple places. Just good practice. Now, if you remember back at the start of this video, I showed that there was kind of a smooth initial start and a smooth stop. So I'm going to implement a smooth step function to better control the distance, better control the motion of that so it looks a little smoother instead of just like being statically incremented by whatever. So to do that, I'm going to add a new function right here. And I'm just kind of putting it in the middle here just because I'm being lazy. You know what? Let's not do it. Let's put it up with our other utility function, which is spawn dust. This is going to be an F32 tree elevator. We'll call it smooth step. This is going to take a position. I'm just going to call this X. And don't worry too much about the math here. Just implement it as I have, and you'll be good to go. So first thing to do is to clamp it, and then we want to return. Let me see if I can get this right. X times X times X. And then it's 15. Yeah, I think that is it. This looks like insane. This is actually just like a factored form of a stepper function that I want to use. How this is going to work, let's write a comment. Accepts a value between 0 and 1, and then returns a smoothed step value instead, something like that. This probably isn't making any sense, and I'm doing a bad job of explaining it. I implemented this a long time ago, so bear with me and let's see if it still works. All right, we want this in our raise function. So first, we need to, we're going to keep this part mostly the same, but we need some other values. Let's say we need our the step size that we're going to be taking. So that is going to be based on the timer. So let's say we're going to have a new value. Let's do this based on how long it take, or how long we want it to take to travel between each position. So tree, elevator, travel, duration, minus this timer. And we're doing minus here so that we get the inverse. And then divided by tree, elevator, travel, duration. So that's going to give us, based on how long it takes to travel from point A to point B, it's going to give us a value in the range of 0 to 1. Right? So say we're at like step 5. This is going to be 40 minus 5 is 35 divided by 40. 35 divided by 40 is 0.85. And you can kind of, hopefully that's making sense. That's all we're doing. We're just getting like what percent complete we are of traveling along our route. So that's our step. I'm also going to add another one here called offset. And here is where we will control our how tall we want the raising to be. We've defined the speed to raise, and instead of just doing this constant step of 2 units each time, we're going to step to a max height. Let's do tree elevator. We're going to have a new macro for this, or a new define, excuse me, tree elevator max height. And we're going to multiply that by our stepper function. So that's tree elevator smooth step. And we're going to pass it the step. This needs to be defined. Define tree elevator max height. Let's see. Let's go back to Blender. We can use the measure tool here and measure how tall our object is. So it's 20 meters tall. We probably don't want it to go all the way. So let's say it's going to go 18 meters. Now, I'm saying meters. Meters are not the unit of measurement in OoT. So just pretend that M isn't there. It's 20 units tall. And we've got our scene scale here is 10. So that's 20 times 10, 200. We want to, let's go 18. So we'll say 180 units for our max height. 180. And this is a float because the position is going to be compared using a float. All right. If the timer is 0, then we know we are at the max height. So let's set it exactly to the max height. So this Dyna actor world pause Y. This actor, this Dyna actor home pause Y. So the world pause is where the actor is in 3D coordinate space in the world. The home is where it first spawned at. So you can keep a it's sort of like just keeping a reference to the world coordinates that the actor had when it was first loaded into the scene. And we want to offset by tree elevator max height. Okay, so this line, what it's going to do is just snap it to exactly 180 units above its home position when the timer runs out. Then we're going to do our weight to lower. However, if the timer is still going, we need to, so So maybe let's not even have an else here. Let's do it like this. We will step up here. Dyna actor world pause Y. This Dyna actor home pause Y. Offset. So instead of having this in the else here, like we had before, where we were setting the Y coordinate to be just like plus equals a constant, I'm actually going to lift it outside of the else, and it's going to behave correctly because of this extra line I have here with this snap. So I'm going to make sure, because of any rounding errors in my stepper function or my smooth step function, it's always going to end up in exactly the right position. So we're good. This should be everything we need to do. Let's adjust. Well, let's just see if that even works. If that's giving us the kind of smooth, gradual rise that I want to see. So it should start off slow, and then once it gets going, it will speed up, and then once it gets near the top, it's going to slow down again. Let me get a good angle on this. There. Because it happens so fast, let's add some duration. So instead of 2 seconds, let's make it take 5 seconds. 100 frames is 5 seconds. Be able to see that smooth stepping a little bit easier. All right, there. Starts out slow, and then slows down at the top. That is exactly what I want. We've got the rise portion working correctly. Now would be a good time to commit. I'll just add everything. Tree, elevator, rising. Good. Sure. There's our raise. Now we need to do our setup weight to lower. I don't think we really need to add anything there. We're just gonna wait for some amount of time. I'm not gonna make another define for this. I'm just gonna say, yeah, we'll wait for 5 seconds at the top, and then go to weight to lower. This doesn't need to change. We're just waiting. Then we go to setup lower. Here's where things are gonna start to get more fun in the lower action func. So this is going to be very similar to the raise, but opposite. So we'll do the same thing. We'll get a step value. So that's going to be this timer F32 tree, elevator, travel, duration. And you'll see it is not this. So here I took the timer minus, or I'm sorry, excuse me. I took the travel duration minus the timer divided by the duration. This got me the step as it was increasing, because the step or the timer is going to be going 0, 1, 2, 3, 4. So I wanted to have the percentage for each unit. Like when the timer was, the timer is going in reverse. So it's going 40, 39, 38, and so on. So instead of it being 95% complete, it would only be 5% complete. Okay, so but now that we're lowering, we're actually moving in the same direction as the timer. The timer's decreasing, and we want our step to be decreasing. So I don't need to flip it. I can just do the timer divided by the travel duration, and that's going to give me the correct percentage. I probably did a horrible job of explaining that. I'm so sorry. I'm not super prepared to explain math, but hopefully that made some sense. Anyway, let's move on. Offset, I'm going to do tree elevator max height times our stepper. Tree elevator smooth step, like so. Decrement the timer. If it's equal to 0, let's do that same snapping thing that we did before. This Dyna actor world pause Y. This Dyna actor home pause Y. And then we set up wait for switch. Perfect. Oh, and we need to actually move the thing. So let's do that here like we did before. This Dyna actor world pause Y. This Dyna actor home pause Y plus offset. There we go. So now we should be moving. Oh yeah, kill this else. We don't need this else anymore. We're not doing it that way. Let's give it a test. Well, let's not wait for 5 seconds. Let's just wait for 1 second at the top. So now we should have smooth going up and smooth going down. Looks good, looks good. Nice. Beautiful. That is a good looking elevator. However, it's missing some things. It doesn't have any sound effects, and I want to have some dust spawn at the bottom. So another good commit point. Commit M states for tree elevator complete. Let's add some sound effects. So let's start back at the start, I guess. So that first sound effect is going to happen when we are raising. We're going to make kind of like a rumble raise sound, right? So I guess we will do this again in the else statement. So this else is when the tree elevator is actually in motion, right? Because that means the timer is not 0 and it's continuing to travel. So here, this is the block that we want to call our function to play a sound effect. And we can do that with, I think it was actor play SFX. Yeah, and we'll pass it this Dyna actor. And I already know what sound effect I want, and it's NASEEV elevator move 3. You can find a list if you Control F for, well, actually, a better way will probably be go to the file directly. Let's say you want to go to like environment bank table. Yeah, environment bank table. Here is a list of all of the sound effects that make up this environment bank. And actually, let's go to environment bank. Here in sfx.h, you can see this enum for defining the sound effect ID is composed of a bunch of different tables at different bases. So you can look at these files, you'll find defines for all of the different sound effects that are used in the game. I already know which ones I want because I have heard them before and I have notes. We're gonna play this one, elevator move 3. Now, an interesting thing about playing sound effects, if you call this function just as it is, it will play this sound effect to completion. What I'm going to do is use this SFX flag. So I take the original sound effect minus the sound effect flag, and this is just a constant value. But the game interprets this as I'm going to be calling this function to play this sound effect every single frame, and when I stop calling it, that's when you should end the sound effect, right? So let's say another way we could do this is instead of calling the sound effect in the raise function, we could call it in the setup function. So call it once and it would play this sound effect until it finishes and then no more. However, I think the raise is going to last longer than the duration of the sound effect. So I want to keep playing it and just keep looping it until we're done. So I'm going to put it down here in raise. SFX flag. Hopefully that makes sense. This SFX flag is extremely weird, and I think the explanation I just gave you is correct. If I if I am mistaken and I get corrected by somebody else, I will put that in the comments to clarify, but I think that's what we want. All right, and likewise, we want another sound effect when it stops, like when it hits the top of its duration. So we're gonna put that here. Actually, we could put it in setup wait to lower, huh? That would make more sense. Sure, we'll put it down here. Let's play actor play SFX. What do we want? That's right, this Dyna actor, and this sound effect is called NASCEV block bound. And you know what? To keep things simple, I'm also going to move this down to setup weight to lower here. Yeah, pop that in there. Play the sound effect, set up our timer. We want this to last for 5 seconds again, sure. And I'll do the same here. World pause Y. I can move that into wait for switch. There. That kind of cleans up our messiest functions, which are the raise and lower functions. Now they are more cleanly doing just the things that they should be. We've moved all this setup stuff. Really, it's the responsibility of the setup function to prepare the next state. So logically, as we're like going through this code, when I hit this if condition, I want to transition into the wait to lower state. So I call the setup function. This will now do everything it needs to in order to successfully and cleanly transition into that wait to lower. So that way, maybe I want to go to wait to lower at some other random point in the life cycle, right? I could just call that wait to lower again, and it would be, everything would work fine. In this case, that doesn't really make sense, but you can imagine a more sophisticated actor that would have many different scenarios and when it wants to transition into a certain state. So putting all of its necessary setup into these functions is a good practice. All right, got our raise sound. Playing our block bound, we need to do the same thing when we're lowering. So here, let's say if we are in the process of lowering, that's going to be our elevator move 3. Oh my goodness. Okay. Elevator move 3, just like that. Now, one difference with lowering is I'm going to call the sound effect to block bound here and not in setup wait for switch, because I know that setup wait for switch is the very first state that it goes into. And if I put it in setup wait for switch, we would hear that sound effect as soon as the actor spawns. And that's not what we want. So I'm going to break the rule that I just explained to you about keeping all this stuff in the setup function. I'm going to put it here because of that edge case. I don't want it to just play that sound effect right away. All right, let's see if we've got sound, and then we can add dust. Let me turn up my audio a little bit to make sure this comes through. All right, give me some good elevator sound effects. Nice. Turn that up a bit more on the way down. That sounds good to me. All right, get this quieter because this is always way too loud. Another good spot to commit. Elevator sound effects. Last step, let's spawn dust. So we're going to change our spawn dust function a little bit and make it a fair bit more complicated. All right. First thing we're going to want to change is the color. So let me pull up a good color real quick. Yeah, here we go. This will be a nice brown. So for the primary, I have 170 in the red, 130, 90, and then for end color, it's going to be 100, 60, 20. And one way to do that, I can show you. I can open up Frida real quick. All right, make a new file. Up here in the color picker, then I can pick a brown like this, and you'll see I'll get the red, green, and blue channels just like that, and I can just put those numbers directly into their respective field here. Okay, so that'll give us a good brown. Next, we aren't going to be spawning this dust at the origin. We actually want to be spawning it at an offset from the origin of the actor. So what I mean by that is, let's go back to Blender to better illustrate, right? Here is the actor's home position. When this elevator is raising up, I want to spawn dust over at this corner, over at this corner, over at this corner, and over at this corner, right? So I need a way to, given the home position, I need to calculate these offset positions for each of the four corners. This is going to be some more fun math. So we know, let's make an array to hold our offsets. That's going to be shorts, offsets, and there are some helpful macros. So we want to use one of them called deg to binang. Binang is it's kind of a made up unit for rotation that OOT uses a lot, and it encodes a full revolution of an object into a short 16. And the advantage of this is when that short overflows and wraps around, it actually just steps right back to where it was. So like if you were doing degrees, you would have 0 degrees up to 359 degrees, and then 360, well, that's actually the same as 0, right? So this binning trick that the original developers did is quite clever, and it means just the natural overflow behavior of the short will handle those cases of duplicate values, and it's much smaller than needing to store a float value. So we can use this macro deg to binning, and that will allow us to convert friendly human degrees to binning degrees in game. So we want what? 90, 180, 270, right? And 0. Put these on new lines. It looks nicer. Right, so those are going to be my degree offsets to travel to. Now this pause, it's no longer going to be the world pause. So I'm going to kill this. All that stuff is fine down there. I'm going to set up a loop here. So this is going to be for u8I, start at 0. We'll do I less than another handy macro, array count offsets, I++. Going to loop from 0 to 4 because we've got 4 elements in this, excluding 4. So 0, 1, 2, 3. And now we're going to start with a pause. So I'm going to start at the home position, pause this actor world. Oops, this Dyna actor, not world, home. When we want to start from the home pause. This Dyna actor home pause. Now we're going to do some math. Pause.x is going to be math sin s, this Dyna actor shape rot y. So this is going to give us this shape.rot. There's also a world. The difference between world and shape for rotation is an actor can have its like display list rotated at a different angle than its actor orientation. You can actually see this with Link, for example. Like when Link is strafing to the side, his player model is rotated forwards, looking at whatever he's strafing at, but his actor rotation is turned 90 degrees to send him off to the side. It doesn't, in this case, our object doesn't rotate, so the world rot and the shape rot are always going to be the same. That doesn't matter at all. And we're going to take the sine of that shape plus our offset, offsets I. And we want this to be some distance away from, let's just start with 100 and see how that looks. So that gives us the x part. Now we're going to do the z part, math, cosine. Yeah, take the cosine of the shape and the offset. And I actually have a diagram. Give me 1 second. Let me see if I can pull up this diagram, and it'll help explain what's going on here a little better. Okay, here is an image that somebody way smarter than me used to help explain why this works to me. So hopefully now I'll be able to explain it to you. Why we're taking the sine and cosine here of this rotation value. If we imagine that r is the distance away from some point, so here at the origin, this down here in the bottom left, this point, this is the origin of our actor. And we want to find a point that is 100 units away, rotated based on some angle. So r is going to be 100 in our example. So if we take this angle A, which is our shape dot rot dot y plus our offset, taking the cosine of that and the sine of that is going to give us the decomposition of that angle on each axis. And then simply by adding them to x and z respectively, it will end with our final point here on the radius of this circle, 100 units away. So hopefully that explains why this math does what it does. I'm getting some compiler errors here. This is like, I'm using GCC as my compiler. So I'll show you. If I do U8I 0, I can do it like that, make the compiler happy. But you can actually just put it inside U8I like this, fine. But sure, I'll leave it out, and we'll just we'll stick this right here. Yeah, why not? All right, hope you're still with me. I know that was a lot. Now I want to change the velocity a bit of the dust. Before we just had 0, 0, 1, 0. I'm actually not going to have it go up. I'm just going to give it like a random velocity, basically. Let me create a random angle. Do a short, and this is going to be random angle. And there's a function to get rand shorts. It's just called rand s16 offset. And let's jump into this function to look at what it's doing. Okay, so it's taking rand01 times some range and adding a base to it. We don't need a base. Our base is going to be 0. And our range is going to be, I don't know, let's just say the full thing. Let's just do deg2 binang 360. This will give us a random angle in binangs of around all possible angles. And then for the velocity, we're going to do something similar, just to add onto just random direction vectors. So we're going to say sine of random angle, and velocity.z is the cosine of random angle. And let's also give this a random radius too. So let's multiply this by some random radius. Maybe more accurately, we should call this random dist. Sure. This is going to be a float, so random dist. Let's just say this is going to be rand 0, 1, random number between 0 and 1. And the distance, or the max, is going to be, let's say 2. So this will give us a velocity vector in the x and z components of at most 2 and at minimum 0. It's just gonna help make the dust look a little better when it spawns. Right. And finally, we can call our dust spawn function. here. I think that is looking good. I'm not seeing any immediate errors, so let's see if that works. Oh, I guess this scale and scale step, these are way too small now, right? So let's see, what should these values be? Let's say we can keep the scale starting at 10, but let's step it up so it's big dust. Let's go to 200 and we'll cut this down to 20. So that's going to be, each dust particle will just be around for 1 second. All right, let's try it. Oh, we're not actually calling this anywhere. Where do we spawn our dust? That's going to be in when it's moving. So that's going to be in raise and lower. So we can put that down here. Tree elevator spawn dust. And likewise, down here, tree elevator spawn dust. Okay. We're in the home stretch. Let's see how this looks. All right, getting some dust around the sides. I think my distance is a little short. So instead of 100, let's go out just a little bit more. Let's go like 110. I think, you know, I could add more so it spawns on like every corner, but I think it's okay to leave it like that. Though I wanted to stop spawning the dust when it slows down. So let's add another catch for that. So let's say for, where are we? This is in raise. So our timer is going to be decrementing. Let's say if this timer is greater than 10, we'll spawn the dust. So this means for the last half a second when the elevator is approaching its final position, it's not going to be spawning dust. I think this will help with the aesthetics a little bit. So greater than 10, let's do the same thing down in lower. Let's replace that. Oops, not make test, make run. I don't know why I keep making that mistake. Here we go. Let's look at our elevator. And it's dust. Decent. Still not happy with the dust. It kind of looks a little odd. Maybe I'm spawning too much of it. Yeah, it's coming out pretty violently. I think part of it actually is the scale. So let's start with a scale of 100, and we'll step by 20 instead, like that. And let's add some jitter to the position that it spawns at. So we've already got our random angle here. Go ahead and add that onto the position as well. So pause X math sin S random angle random dist. We'll use the same stuff as velocity. Well, those. Okay. Yeah. Let's see. I think that's gonna be it. I think that'll look good. No. Not at all. Way too small. So yeah, this scale step needs to be big. We'll go 100 and make this like start at like 400, and then yeah, that might be too much. Let's see. I'm not gonna keep messing with it. This is one of those things that I could sit here and mess with all day until it's just right. But for the sake of the tutorial actually having an end, because this is already probably the longest one I've done yet, let's just go with that. There we go. I know I just said I'm gonna finish, but let's say I want the timer, I'm gonna have it be on both sides. So I'm gonna update this if expression. Let's see, if this timer is, it's gonna start at tree elevator travel duration. It's less than tree elevator travel duration, minus 10, and minus 20. Oops. Copy this guy, and is greater than 20. I can fit this all on one line. That's fine. Okay, so now it will check in both directions. So the dust won't be so aggressive coming out. And one last thing before we look at the dust, I mentioned like when we were running around and testing out the collision that it was making the sand sound effect. Let's fix that. We're gonna do that in the material properties here in Fast64. Open up woodcut and go down to collision properties. And instead of sound dirt, I'm gonna make this sand wood. Yeah, wood, sand wood, sound wood. And I'll do the same thing for the bark. Wood. And then I need to re-export the collision. Okay. This should be our final build of this incredibly long and way too complicated tutorial on making a simple elevator. Hopefully you kind of see why I was hesitant about doing this tutorial in the first place. I don't even know if it's going to be useful to anybody or if anybody will make it to this far in it, but let's see. There we go. That's looking good. And it sounds like wood when we swipe at it. Let's see if it sounds like wood when we walk on it. Yep. Sounds like wood. Doesn't spawn any dust when we roll on it. Okay, so there you have it. A tree elevator actor. Hopefully, if you actually did watch all of this, there were some useful parts. I think this is kind of the sweet spot in complexity. I try my hardest to keep any sort of puzzle actors to be this complex or less. Because they can really get away from you. Obviously, if you're doing something more complicated like enemies or NPCs, things really start to get nasty. But yeah, hopefully this was useful. Last step, let's commit everything. Tree elevator finished. Yeah, get logs. Now we can see all of our history looking good. Okay, that's gonna be it for this video. Let me know if it was useful. Please let me know if it was useful. It would really make me feel better justifying all this time to go over and explain all this. Hopefully it was helpful. All right. If you do have ideas for another tutorial video, also let me know in the comments. This will probably be the last one in the series unless there's some good ideas. So thanks for watching, and I might see you in the next one. Who knows?